So we are doing this homework problem 3.7. So rate of change in the natural science and number 3. So over here we have the graph of this position function. Notice that this one here is the position. Okay. And the t over here is the time, the t, and this s here is the position. Now the first question asks here, when is the velocity of the particle positive? Now we remember the velocity of the particle is actually the first derivative of the position function when the object is moving along a straight line. So it is the first derivative of the position function. So first derivative corresponds to the slope of the tangent. So it is going to be the slope of the tangent. So we're going to draw the tangent line over here. Let's think about from 0 to 1. Okay, so now we try to draw a tangent. So from 0 to 1, from here to here, you see that if you draw the tangent, you see the tangent line right here, it's going to rise from left to right. So the slope of the tangent will be positive from 0 to 1. So that means the velocity will be positive there. So we'll have 0 to 1. Okay. And then let's look at another. From here, what happened to 1 to 3? This is 3. Then you see that the slope for the tangent is going to be negative here because it's actually, you see the slope is negative because the tangent line is falling from left to right. So it's going to be negative here. And then after that, from 3, I think the graph here stopped at 4. Stop at 4 right here. So from 3 to 4, again, you see that the graph for the position function is actually increasing and the slope for the tangent is positive. You draw the tangent line here and you see that those tangent lines over here are rising from left to right. So it's positive. So looking at this, when is the velocity of the particle positive? It's going to be from 0 to 1, right? 0 to 1, and then also from 3 to 4. So it's going to be 0 to 1 and then 3 to 4. Okay, so that's the one. And you can put a union sign in between them, but you can also, if you put a union sign in between them, it's okay. But if you leave that out, just use a comma in between them, then that's also okay, like this. Now I'm going to ask you, when is the velocity of the particle negative?
From 1, 3 because the tangent lines, when you read left from right, are negative.
Yeah, it's falling from left to right. Yes, very good. So it's going to be from 1 to 3. Now the next question, when is a particle speeding up? So the particle is speeding up. It's going to be, I actually have, remember from the, do you remember from the lecture, the lesson? When will a particle speeding up? The particle is going to speed up when acceleration and velocity, they have the same sign, right?
Yes.
If they have the same sign, so say for example, they're both positive, then the particle will speed up. If both of them are negative, then it will also speed up. So both positive or both negative, then the particle will speed up, right? So if you're looking at 3b, we actually have a similar question. Okay, so when is the velocity of the particle positive? So you look at the slope for the tangent, right? Negative here, okay? And then negative here for the slope, and then only positive from 3 to 4, right? And then when is the velocity negative? It's going to be from here, it's going to be from 0 all the way to 3. You have negative slope of the tangent. So it's a similar problem, right? And then For C, it asks when is the particle speeding up. So you see that the in our lecture, okay, look at the lecture. We know that the particle is going to be speeding up when the acceleration and velocity have the same sign. Okay, so you're looking at this, you see that this one, the acceleration here is positive. Okay, so let's make a table. So we will have, so we're going to divide the graph right here from 0 to 1, and then 1 to 2, 2 to 3, 3 to 4. So I'm going to divide them this way. Now over here, and then we look at the sign for the velocity. Velocity is negative here, negative here, negative here, and positive here. Okay, so we know that. So negative over here, and then positive over here. Okay, so we have the sign for the velocity, negative here, positive here. And then we try to make a sign chart for the acceleration also. Then what do? Once you get the velocity, we know the acceleration is the rate of change of velocity. So, and then let's look at the rate of change. So you see right here? You see right here, the tangent, it was tangent like this, and then later on like this, and then later on like this. The slope, what happened to the slope? Is it increasing or decreasing? So this is very negative, right? And now it's less negative, and then here less negative. So it's actually increasing. Right? So when it becomes less negative, it is increasing. So when the velocity increasing, the acceleration is positive. Okay, so you have a positive acceleration. And then what about this? If you draw the tangent line, you see that this is the tangent line, and here is negative, and then it's more negative, and then more negative, right? So if it become more negative, then the velocity is decreasing. Okay. So say here is -1, here will be -2, and then here will be maybe -3. So it's actually decreasing the velocity. So it's decreasing, then the acceleration is negative. And then looking at this one, the tangent line, say here is -2, and this is -2, right? And then here is negative, and it's negative, right? And then here is this. What do you think? Is the slope become more negative or less negative? Here, 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 and here. Okay, just look at this one to this one. Which one is more negative? This is more negative or this is more negative? I think this is steeper, right? This is more negative than this one.
It's more.
Okay. So it's actually become less negative. So when it's become less negative, the velocity is actually increasing. So the acceleration will be positive. Okay, positive here. Now what about this? So you have positive, and then more positive, and then more positive, steeper. So it's increasing. So the acceleration is positive. So we have the side chart for this acceleration, positive, negative, positive, positive. Okay. Now in the future, you can actually, we talk about the concavity test. So when the graph is concave up, okay, kind of like this way, then the acceleration will be positive. When the graph is concave down like that, the acceleration will be negative. Okay, so when the graph for the position function is concave up, then is positive acceleration. Concave down, then is negative acceleration. Okay, so for example, like over here, so we're looking at the graph that we have. This part over here is kind of like part of this. So it is concave up, right? So it's concave up, so it's positive. So you see over here, it's part of the concave up graph. So this is positive acceleration because it's like concave up. Now what about this part right here? This part here, it curved down like this. So part of a concave down curve, right? Like that. So acceleration is negative. Now what about this? From here to here is concave up, so positive acceleration. And then what about this one? Concave up or concave down?
Concave up.
Concave up. So the acceleration here will be positive. The second derivative of that is positive. So it's positive. So concave up, positive second derivative. Concave down, negative second derivative. Concave up, positive second derivative. Concave up, positive second derivative. So, and that way might be a little bit easier to look at. This way may be easier to see the sign for the acceleration. Now we're looking at the sign that the acceleration and the velocity have the same sign, and then the particle will be speeding up. So we see that when would that be? Will be this one, right? So they will both have the negative sign. So corresponding to the time interval will be from 1 to 2. Okay, so 1 to 2, then the particle speed up. And then here, acceleration and velocity have the same sign, both positive. And this corresponds to from 3 to 4. So 3 to 4, the particle also speed up like that. And then what about from 0 to 1? Acceleration and velocity have opposite side, so the particle will be slowing down. And then from 2 to 3, acceleration and velocity, they have opposite side, so therefore the particle will be slowing down right here. Okay, so any other question? So let's go back to this problem over here. Let's make a side chart for this one. This one here actually changed concavity here too. So yeah, we actually had to think about it. Okay, so over here velocity is positive here, and here will be negative here because it's falling, right? It's falling. Okay. However, it actually changed concavity at this point. Okay, at this point it changed concavity. Before that, this is concave down. So the second derivative, which is the acceleration, is what? Negative, right? So it's negative. You got it, it's negative. But then what about this part right here? This, concave up or concave down? Concave up. So the second derivative will be positive right here, okay? So therefore, yeah, this one here, it changed concavity. So from concave down and then to concave up. So it's acceleration here changed from negative to positive at this point, okay? Like this. Now we see the side chart, okay? Now we say, when will the acceleration and velocity have the same sign? Now it's going to be over here and over here. So therefore, it's going to be from 1 to 2, okay? So speeding up. So that will be from 1 to 2, and then also from 3 to 4, okay? And then when will that be slowing down? Slowing down when they have opposite sign. So positive sign, negative sign, positive sign. So that will be from 0 to 1 and 2 to 3. So 0 to 1 and then 2 to 3. Then the particle will be slowing down. All right. I almost forgot this one. Okay, so be careful. And you have to see when does it change concavity.